Hi everyone, what I'd like to show you in this video is how to add HBr to an alkene. And so the first thing we need to realize is that the addition of HX, and so in this case X is Br, is an example of what we call a Markov-Nikov addition. And so the best way to predict what our products are going to be is to actually draw out the mechanism of this reaction. So in this reaction, our alkene is going to act as our nucleophile, and it's going to reach out and attack nucleophilically the proton of HBr. In doing so, though, we're also going to break the HBr bond, namely for the fact that protons or hydrogens in general can't form two bonds. What this is going to do is it's going to create the following product of this step. You'll notice that I've added the proton to the less substituted side of the alkene. This is using what's known as Markov-Nikov's rule, and in doing this we notice that we generate the more stable carbocation. Now we have to ask ourselves the question, is there a way we can rearrange that's going to lead to a more stable carbocation? And so in this case there actually is. If we do a 1,2 alkyl shift, so we're going to denote that by 1,2, we're going to shift this ethyl group over, and in reality you can shift any of these ethyl groups over. What this will wind up doing is creating the following tertiary carbocation. This tertiary carbocation is more stable than the secondary carbocation, and it's actually thermodynamics that drives this carbocationic shift. And so I'll denote this as a 1,2 alkyl shift. A lot of times your book will call this a 1,2 methyl shift, but in reality this is not limited to simply methyl groups. What's going to wind up happening though is that we still have our bromide anion, which is left over from the nucleophilic attack on HBr, floating around in solution. This bromide anion is then able to nucleophilically attack our carbocation, which has a positive charge manifested in an unhybridized p orbital. And so let's go ahead and nucleophilically attack that. What this will wind up doing then is producing our alkyl bromide product. And so what we've shown now is we've added HBr across an alkene. However, because we're forming a carbocation, and by performing a 1,2 alkyl shift we can form a more stable carbocation, our addition of HBr isn't necessarily in the initial position of where our alkene was, which I'm circling shown here, but rather our bromine is attached to the adjacent carbon because of the carbocation we create through the alkyl shift. So in this case, this is an example where it's not simply adding a hydrogen to one side of an alkene and an X group to the other, but rather we need to think about what the mechanism tells us about our reaction. Okay? Until next time, happy practicing.